Today we're going to present the FLEXvalue open source cost effectiveness calculator. And I want to acknowledge Steve Sufian, who is on the line with us as well today. He's the principal engineer at Recurve. And he really put in a ton of work and did some brilliant things with the code to get it into a place where we could release this as an open source package that is scalable and can run for everybody. And Steve is going to be really the main event of today's conversation, because I really would appreciate if folks, engaged in this conversation and actually by the end of this presentation are up and running with this tool themselves. So the goal here is not just to sort of present some slides and talk about, why this is so great. The goal is actually to get people running this tool. And by the end of today, I think anybody who wants to can be running cost effectiveness calculations themselves. You don't have to be an engineer. You don't have to be a subject matter expert necessarily. There is functionality here that you can utilize directly to run cost effectiveness calculations on your own. So just a little bit of background here. For folks who know me, I'm Adam Shear. I joined the energy efficiency world, the demand side world, really 6 or 7 years ago when I started at PG&E. During my time there, I was on the policy team, I was on the programs team, and I was also on the EM&V team. I started in 2014 at PG&E, and at that point in time, we were really worried principally about running great programs. And I think PG&E and all of the other program administrators around the country are still worried about running great programs, but cost effectiveness has become the predominant consideration in many of these jurisdictions. And, from 2014 through about 2018, 2019, that's when folks saw a lot of the cost-effective, low-hanging fruit disappear from energy efficiency portfolios. So things like LED lighting became code. So there wasn't an ability for these portfolios to get a lot of cost-effective savings out of a measure like lighting that could basically buoy the rest of the portfolio. And as a result, the portfolio level cost effectiveness really became a squeeze in a lot of places. And I saw sort of firsthand how the predominant consideration in deciding whether programs lived or died, deciding which programs got scale, which programs got additional investment, versus which programs may have been retired, which programs ultimately receive budget cuts, those kinds of things, it became a question of cost effectiveness. And so when we then sort of tried to dive in and use some of the existing tooling, they were difficult to understand, what was really driving cost effectiveness, what was, what were the levers you could pull, how could you optimize programs. A lot of implementers were tasked in the third-party transition in California with running cost effectiveness calculations. They weren't really set up to do so. It was a little bit too complex for them. And it's difficult to QA, QC cost effectiveness scans if there aren't simple sort of inputs and outputs. So, this really became a rock and a hard place kind of situation where we were trying to optimize our portfolio for cost effectiveness, engage implementers in doing so, because at the end of the day, these were their programs, but had a really hard time doing that because the tooling was set up really for a previous era where subject matter experts were the folks who truly needed to use those tools, and it wasn't the broader population. So that's kind of what brought us here today, and I'll talk a little bit more about some of our motivations as I go on. But I just wanted to introduce Recurve here for a moment. I think most folks here are probably familiar with us to some extent, but our mission is really to take data analytics in a transparent way into the world of demand side programs so that we can compete against supply side resources and scale as a genuine decarbonization resource that people can trust. We're really a software company at heart. And at the end of the day, what that means is we are trying to automate a lot of data processes so that using data in demand side programs doesn't have to be the subject just of impact evaluations down the road, but can be the subject of daily optimization and daily management of programs so that we collectively can come into the procurement space and say, here's why you can trust what we're doing we have a system in place that can play on your playing field. So that's our goal as a company, and cost effectiveness and valuation is a huge part of that. I want to say that this is not a talk really focused on cost effectiveness policy or the theory of cost effectiveness. There are, a lot of strong opinions about cost effectiveness. I happen to have many strong opinions about cost effectiveness and which policies should be in place. So I would just refer folks, if you're looking for a discussion of the advantages and disadvantages of the TRC versus the PAC, and you're looking at, regulatory histories and things like that, there's quite a few resources I would point you to that are in this deck, and we'll share this deck at the end of today or in a few upcoming emails. Now, there's a couple links here. I've already posted one in the chat, and if somebody wouldn't mind just kind of copying and pasting that again, I think folks only can see the chat after they've logged in. But you can take a look at these basically, they're called notebooks. And these are the web pages that will allow you to run FLEXvalue directly. So we have two of these web pages that we're going to cover today. The first is linked here, and this is the FLEXvalue calculator itself. And the second is a tool that we've built specifically to allow you to compare FLEXvalue outputs with CET outputs. So for those who are not familiar, the CET, generally we're referring to the California cost effectiveness tool. And we've built a calculator, or we've built a notebook that allows you to simultaneously prepare FLEXvalue inputs and CET inputs, and then parse the outputs after you've done so, and then get a comparison between the results from those scans. So we'll cover both of these today, so this will make more sense in a bit. But if folks are interested, this is where you can find, and if people don't mind, Steve or Natalie, if you could copy these in to the chat so people can open up these web pages if they would like. And like I said before, the goal here today is to have people actually running the FLEXvalue calculator by the end of this presentation. So starting off just kind of with a status quo picture of cost effectiveness tools, cost effectiveness has kind of become a little bit of a zero-sum game with respect to tooling. There's a lot that goes into a cost effectiveness calculation, and there's a lot that is important in cataloging what comes out of CE calculations, making sure that things are compliant. But if it's too complex, then ultimately the results can't be trustworthy. They can't be used for optimization. It's hard to know what's driving the results. So cost effectiveness has really become, from a tool standpoint, too complex for many users. And that's partly due to an input structure that's a bit complex and was built for subject matter experts. It's also because there's a lot of levers, there's a lot of dependencies or variables in the cost effectiveness calculation. And some of this has led to erroneous results coming from people who are starting to use these tools that never had to use them before. It's also difficult to QA/QC cost effectiveness runs if there are a lot of inputs and outputs that need to be checked. Oftentimes, these outputs are a bit opaque for optimization and feedback, and that leads to programs that could frankly be better. If the goal of energy efficiency and demand side programs is not only to save energy, but it's to save energy at the right times and to drive the highest avoided costs in greenhouse gas savings, then there's a temporal aspect of this that needs to be at the top of people's minds and needs to be something that can readily be probed in cost effectiveness calculations. So if the tooling is difficult to use in that respect, then the programs aren't ultimately optimized for what the avoided costs are telling us where the opportunity is. And then existing cost effectiveness tools often don't represent modern programs. If you look at, I think this may be a little bit harsh or a little conservative, there are not a ton of independent load shape options. I have 7 here, that's what I'm referring to. There's probably more than 7, but if you look just at the DEER load shapes, for example, in California, we have a database of energy efficiency resources. There's approximately 7 distinct load shapes across residential and commercial. I understand there are some other load shapes, and we'd actually like to incorporate them into FLEXvalue, and I'll get to that in a bit. But if ultimately your load shapes that you are incorporating into your cost effectiveness calculation are not representative of the program, then you get an inaccurate calculation. It's just a question of accuracy. There's also a need for custom load shapes to be available for the calculation of cost effectiveness, so that you can optimize programs, so that you can incorporate additional resources. And I'll get to that in a minute. So this is what I mean by complexity. Right now, these are all of the fields that go into a California cost effectiveness tool run. And these are all here for a variety of reasons. Some are compliance checks, some are related to dual baselines, some are, standard things that you actually need in the calculation. Some are with respect to cost information and net to gross, and like a lot of stuff goes in here. But there's 75 or 80 fields that ultimately a user has to keep track of, input into a cost effectiveness calculation. This is again what I mean by complexity. And there's also a question of accuracy with respect to load shapes. So what I'm showing in these top three graphs, these three panels on the top, are the measured savings of a program recently that we've taken a look at. And the bottom three graphs are the load shapes, summer, shoulder, and winter from left to right, that this program is actually claiming. So the program is using these dear load shapes to make savings claim with the commission. And this is what this program is basically saying: here's when we're saving energy, and this is the load shape we're going to use to calculate cost effectiveness. But what we're measuring is the top load shapes, which are obviously very different. So when you plug these load shapes into a cost effectiveness calculation, if you can do so, you get a very different dollar figure. You get a very different TRC as a result. So this is what we mean when we say we need some enhanced load shape functionality. We need the ability to enter our own load shapes into a cost effectiveness tool, especially if we can measure the results directly. Right now, we're essentially taking these measured hourly savings of programs and we're replacing them with a deemed load shape, even though we know that load shape isn't what the program is producing. This is a very difficult proposition for a procurement planner, for example. What we are hoping we can help with here is to actually take these measured load shapes, whether they be from energy efficiency, demand response, any other resource, and say, let's actually value those appropriately, because we know what it is actually. So what's the purpose of FLEXvalue at the end of the day? There's really a handful of purposes. It's to take energy efficiency out of this black box inside of a bubble. This is kind of my modern art view of what a cost effectiveness calculation currently is within the energy efficiency world. Energy efficiency itself is already kind of a bubble, and we all live in it, so we all kind of know what I mean by that. But the black box is like the cost effectiveness tool inside that bubble. And so we kind of need to break this open a bit. And so the purpose of FLEXvalue is to simplify and to bring transparency to valuation. We also want to expand functionality. So giving users the ability to use metered or custom load shapes. And that's really to enable program design. It's not just for accuracy like I was talking about earlier, but it's to say, hey, look, if you have a load shape that you feel can come from an innovative program that a third party can design, then convince us that load shape is genuine. And then we have a cost effectiveness tool where we can actually value that load shape. And if you can remove that barrier, then you can enable things like integrated programs. So energy efficiency plus load shifting, solar PV plus energy efficiency, EVs and energy efficiency. Like, energy efficiency needs to start expanding beyond just measures that save kWh. In order for us to actually be a cost-effective resource, we have to start connecting these dots with other demand-side resources in an optimal way. So integrating resources, that means different kinds of load shapes that we can measure. Planning and optimization, I think that goes along with most of what I've said already. And then potentially we want programs where you can pay on the dollar benefits that you're achieving. So if you can measure a load shape, or if you can project a load shape, and that load shape yields a particular dollar benefit, then you should be able to forecast that. You should be able to measure it. You should be able to pay on it. That's part of what modern pay for performance and meter-based program designs are all about. But we need cost effectiveness tools that can facilitate these kinds of transactions. And then finally, the purpose of FLEXvalue is to introduce an open governance model. Cost effectiveness is a critical factor for so many of these programs. And we have policies that need to catch up and need to get ahead of where cost effectiveness ultimately can take us. And that means we need tools that can actually facilitate policy, can foster smart policy, instead of holding us back from actually implementing policy or the spirit of policies that are already on the books. So this is what we're trying to introduce with FLEXvalue. So I just want to revisit this for a second. Here's all of these fields that go into a current cost effectiveness calculation, at least in California. And what you really need in most cases to accurately calculate cost effectiveness are these fields. So, we go from 75 or 80 down to maybe 12 or 13. You need cost information, you need some program information, what are your savings, what's your net to gross, what's your EUL, things like that. And then you need information on the benefits side. So your avoided cost data on an hourly basis for electricity, for gas, I think it's monthly. And then you need to know what your discount rate is. It's a net present value calculation at the end of the day. And of course, none of this matters really. I wouldn't just say, trust us, we've sort of done this. And the reason you should trust us is because we've done some extensive testing against the current CET. And we've tested FLEXvalue TRC outputs and benefits and cost outputs against the CET. We've looked across, I have 130 scenarios here. This is well over 250 at this point. But these graphs are just showing 130 independent scenarios from some of our initial testing where we were changing the load shape that we were incorporating into the calculation, the program administrator, the climate zone, net to gross, EUL, savings, cost information, everything that we could tweak and change, we did. And we have always seen that FLEXvalue is reproducing CET outputs to within 3%. And I would say, again, you don't have to take my word for it. You don't even have to just believe these graphs. We actually provide a tool that users can simultaneously generate FLEXvalue inputs and CET inputs, and then parse those outputs right on the spot and compare them. And we'll cover that later in this presentation. So again, don't take our word for it. We have verified against the CET, you can do the same. And this is why when we then look at these load shapes that we're measuring, we can actually do the cost effectiveness calculation. We can value those resources, and the dollar value that we are measuring with FLEXvalue based on the results of forecasted or even measured hourly load impacts are trustworthy because we've already verified that FLEXvalue meets the cost effectiveness tool when we're using the deemed load shapes. So again, this is just an example of here's the measured load shapes, here's the dollar benefits, and here's what's being claimed for this very same program. Very, very different. So what are the FLEXvalue tools? What are we really talking about here when we get into the details? There's basically three components of this toolkit. On one hand, the data itself is very, very valuable and can be used for lots of different purposes. And it's a little bit hard to get to at times. So one of the things that we've done in releasing this open source code package is to put together databases that you can download directly. So among these databases include the electric and gas utility avoided costs. If you're familiar with the avoided cost calculator itself, it's something that the CPUC puts forward every year. And E3, the consultant, has done a lot of great work in putting together the avoided cost. This is a really phenomenal resource. But the avoided cost data comes in the form of a Excel macro-driven workbook. And so you kind of need to toggle through many, many different scenarios in order to pull the cost information that you ultimately want. It's a lot of sort of manual copy pasting. We've pulled all of that information for every utility, climate zone, year combination, and we've pulled it all into one central database. And you can download that database as a CSV or as a SQLite table and just use it directly. You can query it directly. and there's no sort of macro driven interface that you have to sort of, figure out in order to get these data at your fingertips. Also, GHG emissions rates are included in these database tables, and then we have deemed load shapes. So all of the DEER load shapes for all of the utilities, we have, you can just go download them directly. And then we have the calculator itself. So this is kind of like the main package. This is the fully functioning Python code base. It's a cost effectiveness tool in and of itself. You can use, again, custom 8760 or the DEER load shapes. It has a notebook user interface, and we'll talk about this and we'll demonstrate it in a minute. And then it's fully documented. So we'll talk a little bit about where you can find all of the nitty-gritty details in the documentation in a moment. And then finally, there's a CET and FLEXvalue comparison tool. This is a tool that, like I said, that allows you to simultaneously generate input files and then parse outputs and compare them directly. So what does it actually take to run a FLEXvalue calculation? This is an example of an input file. So if you upload this as an input file, as a CSV, directly into FLEXvalue, this is what you need in order to run a cost effectiveness calculation with FLEXvalue. Again, this is everything. You're not missing anything at this point. If you're using just DEER load shapes, this is all you need to run cost effectiveness. Now, I want to draw specific attention to this, this one field. So let me back up just a minute. Let's walk through this just for a minute. So you have an ID for every row. Each row contains a load shape. So each one of these rows could be like a measure or a program that you're reporting. It would typically be a row that would just go into the cost effectiveness tool. So if I just look at the second row, for example, I give it an ID, I call in a load shape, I give it a start year and a start quarter. Whoops, what happened there? That's kind of interesting. My computer is not happy all of a sudden. Give me 1 second. Sorry about this. Okay, we're coming back to life. Okay, so back to business. So we have an ID, we give it a load shape, we give it a start year and a start quarter, the utility, a climate zone, the units. So this is just like if you have multiple units, that's basically saying, we're installing this measure more than once. An EUL, a net to gross. You can actually input the discount rate into FLEXvalue. So this is something that if you want to investigate the impact that the discount rate is having on cost effectiveness, you can change this discount rate. We have it set as a default of the discount rate that PG&E utilizes for cost effectiveness calculations, which is 7.66%. And then we have admin, measure, and incentive costs, the therms profile that you would typically incorporate into the CET. And then you have your savings information. So therm savings and megawatt hour savings, these are annual savings. Now, looking specifically at this load shape column, what FLEXvalue will do is it's going to look at each of these load shapes and it's going to say, if this load shape is stored in the database that I mentioned earlier, then FLEXvalue is going to use that load shape. So for instance, this is one of the DEER load shapes. It's the residential HVAC air conditioning load shape. And if you input this load shape, it's going to pull that 8760 profile directly from the FLEXvalue database. And it's just going to use that for the cost effectiveness calculation for that row. Similarly, the HVAC chillers on the non-res side, that's another example of a DEER load shape. But you may notice this res heat pump electrification. This is not a DEER load shape. It's not something that FLEXvalue is going to recognize as a pre-stored load shape. So if you have a load shape that doesn't match what's already in the database, then FLEXvalue is going to expect that you're uploading a second file. In this second file is the 8760 load shape for whatever you want to put in here. So in this case, this is actually, what I'm showing is actually the load shape for electrification, heat pump electrification that we've measured for SMUD. And so this is the load shape that, this is the impact on the electric grid for an average heat pump installation, replacing a furnace in SMUD territory. And if FLEXvalue doesn't see the load shape as being in the DEER database, then it's going to look for this very same column in the metered load shape table, and then it's going to pull that data directly into the cost effectiveness calculation. So again, if you're only using pre-stored load shapes, then this user inputs file is all you need. If you're wanting to use custom load shapes, then you just have to make sure that you're titling that load shape the same as the column heading in the metered load shape table that you're also providing, and we'll show you exactly how to do this. Currently, we have, I think, 17 or 18 DEER load shapes that are in FLEXvalue. This is an understatement because PG&E and SCE and SDG&E and SoCalGas all have different variations on these DEER load shapes. So for example, the residential indoor CFL lighting load shape is different for PG&E versus SCE and SDG&E. And so we've incorporated all of these load shapes, and this automatically, the proper load shape automatically gets selected because you're including in the FLEXvalue input the utility. So it's just going to pair that utility with the DEER load shape in order to pick the proper DEER load shape for the calculation. And then finally, just a note on load shape normalization. The DEER load shapes are all normalized, meaning if you add them all up across all 8760 hours of the year, you get a value of 1.0. And because they're normalized, when you then include a megawatt hour savings or if it's kilowatt hour savings in the CET, then those savings get distributed across that 8760 profile according to how the DEER load shape weights each hour of the year. In FLEXvalue, you can provide normalized load shapes, in which case in that savings column, you would just use it the same way you would use the CET. Or alternatively, you can put in a load shape that's not normalized that actually has the values, you know, across those 8760 hours that you're intending. And in that case, you would just put in 1 in the savings column. So if we look at this res heat pump electrification, then I'm just putting 1 in the megawatt hour savings because this load shape already has the absolute magnitude of the values that I'm looking for. So again, just use this accordingly and you'll be fine. So there are 3 options. Well, there's really a couple options for running FLEXvalue. Option 1 is this Colab notebook. And for folks, you can go to the chat and this link should already be pasted in the chat. So if you click on this link, then you'll open up this notebook, and this is where we're gonna start focusing our attention when we're getting you up and running. No code experience is necessary to run this. You'll see some code and it can be a little discombobulating to see code, but if you can just focus on the fact that you actually don't need to write any code, it's not as intimidating. And then there's a user input file and the optional metered load shape file that I talked about a minute ago that you'll need to upload. We'll provide some template examples of these, so you'll have a starting point. Option 2, for more advanced users, there's a Python library. It's, you know, again, it's fully open source. You can download the avoided cost and load shape tables, clone the repo, import FLEXvalue, the class, and then use these classes and methods. And there's a full tutorial that Steve will give you a little breeze through where you can actually see everything that's going on under the hood. And for advanced users, this may be your preferred option. And then finally, you know, in the future, we'd really like to see FLEXvalue integrated in a full web interface. I hope users, you know, get some experience running this stuff, and ultimately there's some support from the community in doing something like this. But there's no reason that FLEXvalue can't be made, you know, very user-friendly with a nice website that's devoted to it. And as next steps, you know, we want to engage the user base. We want to add functionality if it's desired. So one of the things that FLEXvalue doesn't do right now, for example, is dual baseline calculations. We could code that up, we can get it in there. It's just not part of the initial package that we're releasing. Um, we can also incorporate additional deemed load shapes. So I know there are other like custom load shapes that are used in the CET, these E3 load shapes, for example. I actually don't know where they live. If somebody knows where they live and wants to send them over or let me know where we can find them, then we'll get those incorporated into FLEXvalue in the same way that the deer load shapes are already in there as well. And then finally, there's a wide world outside of California. We'd really like to take FLEXvalue and be able to propagate an open source and common set of tooling that folks can utilize for cost effectiveness calculations even outside of California. So with all of that being said, I want to introduce Steve Sufian, who can take us through actually running FLEXvalue calculations. And Steve, if you don't mind, I'll stop sharing my screen and you can take the baton and we'll go from there.
Yep, just have one question in the chat from Anne. It's whether our end game is to replace the CET with FLEXvalue.
I think the CET is a really amazing resource, and but it's been built for a little bit of a different time in the industry, as I talked about in some of my introductory remarks. I think if folks find FLEXvalue to be user friendly, and not in too much of a political competition with the CET, then I'm hoping that we can kind of settle on an open source governance structure as something that's healthy for everybody. And so I think we'll just see where that goes. What I would actually say is that's not a question for us to answer so much as it's a question for everybody else. If folks are using FLEXvalue and they find that it's has the functionality that they need and is more user friendly and those kinds of things, ultimately, I think the CPUC, we've had really good conversations with the CPUC about this. They've seemed open. And I think everybody has the best intentions. So I would say, folks use it, see what you think, and then we can go from there collectively.
Cool. All right. So again, I'm Steve Suffian. I'm going to walk you through some of the code and also some of the those notebooks that we've been mentioning. One more link I want to put in the chat is a link to all the documentation for FLEXvalue, which also in it has links to these other notebooks that we're talking about, as well as the tutorial. So I'll just put that in the chat. And here you go. Can everybody see my screen? Yeah.
Looks good, Steve.
Okay, cool. All right. So here's this. Here's the read the docs. So read the docs is like a common set of documentation for Python libraries on the internet, and this contains all the information. Most of the information that Adam's gone over, including the Colab notebook links and some more detail about the avoided cost data and the different tables. So I'm first just gonna, so this first Colab notebook is that link that we sent you originally, which is how you can run FLEXvalue directly, where you put in your own user inputs and your own metered load shape. The second one is that CET comparison tool. The third one is an exploratory tool to let people be able to plot the deer load shapes that we have available and download either the deer load shapes or the avoided cost data as CSV files. And then this fourth is the tutorial for more advanced users. And so the rest of this documentation just goes through. Also here's the link to the actual SQLite database, which is how FLEXvalue runs the code. But like I said, this notebook allows you to download these components in CSV. And here's all the different components. There's some more information about the user inputs file that Adam went over and the format, as well as the metered load shape file and some information about how to run it locally. Okay, so now hopefully everybody try to follow along if you're able to. We hopefully can have everybody be running this at the same time. So if everybody can click this first link, if they haven't already, which will bring you to a page that looks just like this. Called.
And this is the link in the chat, by the way, as well.
Yeah. And what we're going to do is if you can see on the left here, there's this little play button. And what we're going to do is we're going to just run each of these steps of code. And I'll go over exactly what's happening during each of those steps. But if everybody could just first click this first one, it might come up with the screen, click run anyway, and then also click the second one. Just do that, and I'll start talking a little bit because it takes about a minute or two. What's happening in these first two cells is, in the first one, it's installing the FLEXvalue package that has all of the code. And the second one is the one that takes a bit of time because this is downloading that SQLite file locally into this notebook. So when you run this notebook, it's actually running in your own sort of Google managed space. And so it's not like if you run your load shapes in here that will have access to any of that data or anything. This is actually making a copy in your own sort of Google space. And so because of that, it has to download the full avoided cost information down into the space so that it can use it in the subsequent steps. Another thing that you can see is it's pointing to the year 2020. So the idea of this is that you can easily be able to download the 2020 results. And once 2021 comes out, you'll be just flip from 2020 to 2021, be able to download the newer cost effectiveness, the newer avoided cost data, and be able to easily compare how things may have changed between the years and everything like that. So this seems to have finished running. And so the next thing we're going to do is we're going to hit the same thing on this cell right here. This is just importing some other Python libraries. Then we're going to run this cell right here. And what this is saying is this is essentially providing an example user inputs file so that we can all sort of download this file if you click on this link, and we'll be able to then run it. And this file points to points to some, well, we'll open it up, but it points to that same SMUD load shape that Adam mentioned. And so you can see how it looks here. It looks very similar to the one that was in the PowerPoint. And so once you have this downloaded, oopsies, run this next cell, and that'll give you a little button here called Choose Files. And so we're then going to upload that file we just downloaded to our computer into this notebook space. And so example user inputs metered. Okay, and you should see something like this. And I'm just going to pause here in case anybody has any trouble getting to this step. So far, we've just sort of like downloaded the avoided cost data into this notebook and downloaded our user inputs file. All good in the chat, Adam?
Yeah, I'm taking a look here. 1 second. I think so.
Okay, so this next file just shows that we successfully sort of uploaded this into the notebook, and it's just displaying the same user inputs again. And so we're going to do a similar thing for our custom load shape. So you don't have to provide a custom load shape if you're only using these deer ones, but in this example, we're going to pull in the custom load shape as well. And so we also provide an example file that matches with this custom load shape. So you can also download that. And then if you run this one here, click choose files, and you upload the custom load shape file. So now we have both the user inputs file and the custom load shape file in the notebook. Okay, so that was all the prep steps. This is where all the meat and potatoes are. So when you run this is actually, you saw he mentioned this FLEXvalue run, which is the name of the class in the library. And this is actually doing the calculations using FLEXvalue. It's pointing to a specific database year, like I mentioned, so to make it easy to be able to run it for different years. And it's also passing in the load shape that we uploaded. And here's the results. So this includes all of the input data as well as the TRC, the pack, electric and gas benefits, the GHG benefits, that it broken down for each row. We also have it output where it recalculates the TRC and pack for the combination of all of those into a single sort of output. And then you click this. If you click this cell, it'll download those results onto your computer so you can use them for everything else. And then we also have this final cell, which if you run, it actually takes the results and provides a number of plots to make it easier to interpret what actually happened here. And some of these will look sort of familiar because they'll be similar to the ones in the PowerPoint. Yeah, and if everyone's gotten that far, that is FLEXvalue. That's how we run it here. I'll take another pause just to see if everybody made it to this place, and otherwise I'll show some of the code and some of the more advanced documentation.
And while we wait a moment for folks to, and please do, if you are, trying this and having any trouble, please do chime in the chat. I think if you're having trouble, chances are other people may also be. And while we're waiting for folks to let us know if they've run into any issues in the chat, let me just spend one moment and kind of walk through these plots, because I think that at the, for folks who are new to this, these plots can be really, really powerful displays of what your program is accomplishing. So what we start with are a series of load shape plots. So these top three panels on this graph, the red, the blue, and the green from left to right, are the average daily load shapes by season for the combination of measures that you input into your FLEXvalue scan. So if you have 10, 20, 30 measures or programs that are incorporated into a FLEXvalue scan, then this is the weighted average load shape of or it might be just the total load shape. I'm sorry, it's like the total average daily load shape corresponding to the summation of all of those rows that are in your input file. And then those translate respectively into those next three panels below, red, blue, green, that show you the avoided costs that are calculated each hour of the day during the summer, shoulder, and winter months. So you can see how your load shapes actually translate directly into avoided costs. In California, the summer peak hours are much, much more valuable on average than the rest of the year. So you can see that the spike in avoided costs relative to the shoulder and winter seasons especially is really pronounced in that summer avoided cost curve. And that's a reflection of the fact that a cost effectiveness calculation is a combination of the load shape and the avoided cost profile. So if you scroll down a bit, you also get a plot output that gives you all of the value stack of the avoided costs. So for folks who are familiar with the California avoided costs, there are 10 distinct value streams that are incorporated into the electric avoided costs. And right now, I should say all of these figures are devoted to the electric avoided costs. We may add some on the gas side eventually. The cost effectiveness calculation itself, like the TRC and the PAC, do include the gas component. So don't worry about that. These figures are mainly focused on the electric side, but you get the full value stack by hour of day for, again, the sum total of all of the measures or portfolios or whatever you included into the cost effectiveness calculation. And then if we keep going, you'll get just another breakout with some information of the avoided cost profile, the savings load shape, and the ultimate benefits profile. And then we provide some heat maps. So this heat map, the top one is showing you the GHG savings by month and hour. So you get a heat map across, month on the x-axis, hour of day on the y-axis, and you can see, for instance, that in this program, the greenhouse gases that are being saved are kind of concentrated into the sort of summer peak period when the grid is fairly dirty and when you're also saving quite a bit of energy. And given that there's an electrification measure in here, a heat pump, you actually see that there's some negative GHG corresponding to when that heat pump is added load to the grid. And you can see that in red. And then you get the same kind of heat map representations of the avoided costs and the savings profile themselves. So savings on the left, avoided costs on the right. And then finally, we provide some cumulative sums to see how savings and TRC benefits accrue over the full 8760 hours of the year. So, you can really see that the savings have a different profile than the TRC benefits do. And then the very last graph it shows you all of the components as they accrue over all 8760 hours of the year for the TRC benefits. So with that, I don't see any comments yet. So Anna said, had a small logistical issue. PG&E network computers don't allow us to log into Gmail accounts. Interacting with Notebook requires a Google sign-in. Anna, let's get back to you. Maybe there's a way that we can figure out a slightly different interface that would allow logins for folks at PG&E. But I'm glad you were able. Oh, and Mananya says she was able to get in. So Mananya, I'm glad that you got in. I'll follow up with the PG&E folks and make sure that this is functional for you one way or another. It's like I said, you know, we want this, certainly if utility folks have like firewall issues, then we want to make sure that we get those solved. Okay, so yeah, Steve, back to you. Maybe we can take a look at the rest of the library here.
Yeah, so I'll go into, so all of this code is hosted on GitHub. And so this is, you can see the similar README down here with all that information. And here's where all the code is. And if you want to look at where the actual calculations are going on, there's this folder called FLEXvalue. And then inside of it, there's a few different Python files. The calculations one is the one that contains really the meat of everything. And in here, you can sort of see all the different functions, the quarterly discount, the TRC cost calculation, and the pack costs. Here's the class object for an individual row. You can see it calculating TRC electricity benefits and all the other stuff. This is where all the actual calculations take place. Then there's also some of these other sort of helper things, one that generates the examples, the plots, the thing that runs what we'll show in a second, which is the comparison tool to the CET. And yeah, what was it? Yeah, and I think that's where all the code is. There's also one more thing, is that there's this tutorial. So this tutorial is similar to what's in the collabs, but it sort of goes through how to run the things in Python a little bit more, and there's a lot more documentation. So again, it explains the deer load shapes, shows how you could directly connect to the SQLite database. It provides all the different deer load shape options that are available, all the different climate zones and utilities. And it explains how to use FLEXvalue, both using a CLI command or using Python. And here's the plots that you've already seen. So this view isn't like a dynamic view where you can upload your own things, but it's sort of a static image of FLEXvalue being run. And I think that's everything I wanted to show on this front. Yeah, again, any questions, let us know. If you run into any bugs. Obviously, it would be great if people ran this thing and found changes or improvements they wanted to make and contributed to the code base, because that'll be what makes it stronger. And with that, Adam, do you want to go into the CET comparison scan?
Yeah, sure thing. So I'll spend a little bit of time here, and then we can open it back up for questions. And if we have a little time at the end, which we may or may not, then Steve can also show the notebook that allows folks to compare and to plot out the deer load shapes themselves. So I'll go ahead and share my screen again. And this time, and Steve, would you mind pasting in the link to this notebook as well?
Yep.
And so I'm just going to kind of roll ahead here, but folks can follow along when they get logged in. So the first two cells are identical to the notebook that Steve just ran, where I'm installing FLEXvalue, and then I'm downloading locally these avoided cost data so that we have the information just on hand to go ahead and run these cost effectiveness calculations. The next cell again is pretty similar. You just hit run and it goes and it imports some Python that you need. Finally, this is kind of the main event. So I'm just going to take a minute to explain what's going on. There are a handful, like I said earlier, of inputs that you need in order to run cost effectiveness calculations. Some of these inputs, the sort of nomenclature, the semantics of them differ a little bit between the CET and FLEXvalue, although we've tried to keep things where it makes sense pretty common between the two. And what I want to talk about is how you can prepare files simultaneously for FLEXvalue and the CET that you can then compare the outputs. And we'll walk through an example of how you can do this. The first thing is just to kind of get oriented toward the information that's here. Now, one of the things I want to point out, which is a little bit of a caveat, but it's an important caveat, is one of the issues that the CET has is that it starts the net present value calculation, like the discounting of TRC benefits, at a set fixed point in time, no matter when you actually start your program. So if your program, if you want to use a cost effectiveness tool to start calculating TRC benefits in 2023, you know, quarter 4, 2023, or even if you're doing like an ABAL for next year, and you're saying, okay, I want to forecast my program, and I'm going to have quite a bit of program participation that's occurring in quarter 3, 2022, then the net present value calculation in the CET is starting in Q1 2021. And that creates a misalignment. That's actually an issue in the CET. So in order to get an apples to apples comparison between the CET and FLEXvalue, because that's not an issue in FLEXvalue, we don't have that issue in FLEXvalue. So in order to get an apples to apples comparison, you need to start in 2021. So we've made that just your program year is 2021. And now you can change your program admin, so you can be PGE, SCE, or SDGE at this point, depending on your utility. And then you just need to make sure that your climate zones are, you know, in that service territory. So right now we have an example set up where you have PGE, you have climate zones 4, 3A, and 11. And where you see multiple values here, so like climate zone, megawatt hour therms, etc., these are just like different rows in an input file. So this would be like having 3 rows in an input file, one with climate zone 4, the second with 3A, the third with 11, and then the corresponding values for all of the rest of the inputs are all, you know, tied together. So, you know, the first row in the input file would be climate zone 4 with 111 megawatt hours, 200 therms, you know, 1 on the units, not 0.95 for the net to gross, EUL, etc. And so that's just true all the way down. And so right now, you know, we have basically 3 rows. You can expand this. So if you want 4 rows, 5 rows, 100 rows, whatever, you can expand this as much as you want. So let's just kind of change a few things around. These are just the default settings. So let's go ahead and put in, say, climate zone 12. If anybody wants to chime in the chat and give me just kind of a number, say anything between like 100 and, or maybe 50 and 150, then I can include that. But, you know, megawatt hours, let's just pick something, let's say 128.9. Therms, maybe we'll have, you know, 35 therms for this row. We'll have 1 unit, we'll stick with that. Net to gross, maybe we can make net to gross 0.48. The EUL, why don't we go 12 years with the EUL? And then we have the sector. So you can choose res or non-res for the sector, and then you'll have corresponding load shapes. So if we wanted to do, if we wanted to change one of these load shapes, we can do DEER HVAC efficient AC, which is a res, you know, load shape used for res applications. And then gas sector, we have residential. I believe you can have like core or commercial. So we'll just change one to commercial. Commercial. And then you have gas savings profiles. So you have annual, winter only, summer only. You know, we can change these around if we want. Maybe we'll make this one also winter only. And then you have avoided cost information. So admin costs, measure cost, incentives, we can change this around as well. So maybe we'll go 2000. Let's just pick like 51.29 for the measure cost. Incentives a little out of whack here. Maybe we'll bring this down to say 2047 on the incentives. And then I'm good. I have my parameters set up for the generation of an input file. Now I can go ahead and run this cell, and it's going to automatically spit out a the FLEXvalue input file. So here's my FLEXvalue input file. And it's just now I'm already set up to run the FLEXvalue calculation. But the first thing I'm going to do is actually download a automatically generated CET input file based on the parameters that I just gave this notebook. So I've just downloaded a file. It's called test run. And you can see it just in my downloads folder. So here's testrun.zip. And it was just created, 4:29 p.m. I'm on Mountain Time these days. And now we can go ahead and run FLEXvalue. So I'm going to go ahead and we'll run FLEXvalue. And while that's going, I'm going to head over to the CET and I'll choose my file. And so I've got test run, the same file I just created, and I'm going to go ahead and run the CET. And we'll hold our breath and we'll take a look and hopefully we have a successful CET run. Right now it's processing, and I will in a moment be able to download the CET output, assuming all of these inputs are kosher. So all the QC was passed. That's a good sign. And in a moment here, I should have my CET output. And here we are. So I can go ahead and download that. And now you can see that show up in my, here's my CET output file that I was just downloaded into my downloads folder. So we'll come back to our notebook. And now this cell allows you to download the FLEXvalue output. I don't necessarily need that right now. So I'm going to go ahead and run this cell, which will allow me to upload the CET output. So I'm going to choose that file that I just got from the CET. And now everything is basically set up. So now the last cell here will allow me to just get this is going to parse out the CET inputs and outputs along with FLEXvalue, and we'll see how we did. So first things first, I can take a look at my CET versus FLEXvalue for each of these measures. So the measure that we just developed together here, this is the TRC benefits from the CET. Here's the TRC benefits on the electric side, and then gas benefits. And I have TRC costs. And overall, I can take a look at my TRC CET versus FLEXvalue. I'm calculating in the CET 10.66 versus 10.79 in FLEXvalue. So I don't know, doing math in my head, it's within a percent or two. And then PAC, same kind of thing. So 14.52 versus 14.70 in FLEXvalue. And this is exactly the process you can go through if you want to, run scenarios and compare the CET outputs to FLEXvalue. And I would definitely invite anybody to do this. And if you find cases where things are wildly off, let us know. We've yet to run into them. But I think for the most part, we're within 3% virtually every time. If you're finding stuff, beyond 5%, then definitely let us know. There are some known reasons why the CET may be slightly different than FLEXvalue. So like little discrepancies are not of big concern at this point. But if there are like major discrepancies, then we'd like to know. So anyway, that's how, like I said before, you don't have to take our word for it. You can find out for yourself. And so now with the rest of the time here, I think we can either spend a little time and Steve can show the Deer load shape tool. That's another notebook available through the FLEXvalue code base, or we can answer some questions. And I don't know if we need to get people off of mute in order to do that, but we should do so. If people want to just speak up, we can answer any questions that folks may have.
Adam, this is Anne again from Energy. I just wanted to say that I can't believe that it makes it that easy to create a CET input file. Oh my God, that alone is huge. The fact that you really only need about 15 fields to input, and the format is you don't have to worry about the format, right? You just give in the values, and there's no funky stuff going on with, you know, formatting and all that. That alone is huge value to our company for sure. But yeah, it's pretty cool.
Well, thanks, Anne. You know, yeah, some of the story behind that is basically as we were, you know, we felt like it was critical that we ran a lot of comparative tests against the CET so that we could say with some confidence that we were doing things the right way in the calculations themselves. And in order to do that,